procedural programming is not very common to folks, but in the database world, procedural programming is something that has been around for a while. And Snowflake being able to support procedural programming is a big deal. And we're going to see why that's such a big deal. Greetings, everyone. Welcome to the channel. Welcome to the show. My name is Furunde, host of Demohub. Today, we're going to be talking about Snowflake Scripting. Now, Snowflake Scripting is a capability that was recently released by Snowflake. It went into general availability, meaning it went GA, available to all Snowflake accounts. And what we want to do in today's video is to talk about that capability, why it's such a powerful capability, but more importantly, go into actual demonstrations of the capability and even tutorials you can follow step by step and see how you can take advantage of Snowflake scripting to apply that to your use cases and to your workload for data engineering, for data science, or just data processing as a whole. So let's bring that. It's going to be very, very hands-on. We're going to be walking through some scripts here as we go through. And before we go in, I just want to call out that the demonstrations we're doing is going to be available on the platform we're building. This is a community platform called Demohub.dev. Demohub.dev. Link to Demohub.dev will be in the description below. I will highly encourage everyone to check it out if you're working with modern data tools and you want to see demonstrations of these tools beyond just what we do with Snowflake. I'll recommend you go to Demohub.dev, you create a profile, and you can see a catalog of dozens, if not hundreds of tools available here. You can search for your specific tool. Let's say if you're working with data governance, you can search for Tonic.ai is one which we did a demo recently, and you can come in. If you have your own demo, you can add them here. Otherwise, we're going to be doing demonstrations of different companies. I'm putting them up here on Demohub.dev, so you can add a new demo if you want, if you have an existing demo somewhere, or you can just watch a demonstration of this particular product, which we've done available on the platform as well. Demohub.dev is a centralized platform, as it says, that democratizes access to demos to elevate and to educate the community, so we're all up to speed with the new products that are coming out, their capabilities, and we can see them all in action. Just a little spiel of Demohub.dev, link in the description below. Now let's go back into the core of today, which is what we're going to be talking about: Snowflake scripting. So we know Snowflake has transformed how companies do data management at scale. Everything from ingesting data, storing that data in a very cost-effective fashion, and then deploying programmability on that data, leveraging SQL, Java, Scala, Python, and you name it. Now, saying SQL and Snowflake sounds natural to a lot of people, but mentioning Java, Scala, Python, or even procedural programming, it's not very common to folks. But in the database world, procedural programming is something that has been around for a while. And Snowflake being able to support procedural programming is a big deal. And we're going to see why that's such a big deal. Now, what exactly is Snowflake scripting? If you go, and the link to this release will be in the description below, as always. If you go to the website, what it does is it allows you to leverage SQL, which folks already do today on the Snowflake platform. It's an extension to SQL that allows for support of procedural logic. You can do more procedural logic using SQL and run that as stored procedures or outside of stored procedures. It's a lot of stuff there. It's very dense, but we're going to unpack all of that as we go through in the demonstration. What exactly is Snowflake scripting and why should we care? Let's go into scripting, because there is a reason why it's called Snowflake scripting and not just Snowflake SQL, and we're going to see why. So the world of programming has different camps that have existed out there in the wild. One of them is the idea of declarative programming. And if you think about what SQL does, you say what you want and the language takes care of doing the work for you. These are some of the characteristics of declarative language, where you focus on what is it you want, not how to get it done. Variables are not mutable. The language figures out the how, and you tell the language the what. For example, if I'm trying to select from my users, I say select from users where username equals John, basic SQL language. I think everyone can understand what's going on here, right? We're telling what we want to do, and the language takes care of executing it behind the scenes to give us result. Now, how is this different from procedural language? Now, with the procedural language, you're actually telling it, or scripting language, there are different ways we can call this. You tell the code or you tell the function what to do. Here, we're not just declaring, say, select from table or create table or join to tables like we'll do in declarative. We're more creating a procedure. Here, you see things like loops, conditioners, branching, nesting, and a whole lot of stuff, right? You're almost now telling the program what to do. If I want to iterate through a list of collections and do something with it, you're going to actually tell the procedure what to do. All right. At the very fundamental level, this is the two differences between declarative versus procedural language, and sometimes called imperative, which is under the bucket of procedural language. SQL would be your declarative language, but if you extend SQL into the scripting world, now you have a procedural language. JavaScript is a procedural language, whereas SQL is a declarative language. So hopefully this foundation clears up things for us. Now let's dive in a little bit what Snowflake has offered. In the past, you can come into Snowflake and create a stored procedure in Snowflake leveraging the power of JavaScript. Now, JavaScript is a procedural language, meaning now if you have JavaScript in Snowflake, you can create a very complex logic. You're not going to be building a front end with this version of JavaScript, which we all know what JavaScript does, but you can do some really advanced curation or analytics by leveraging the power of JavaScript and procedural language inside of a Snowflake stored procedure. That is out. It's been out for a while. People have been using this. If you can program in JavaScript, this will be a big, big plus for you. People love it, this JavaScript capability. Now, but there are folks that are not JavaScript connoisseurs. They don't know JavaScript, nor do they want to learn JavaScript. And we're not getting into the debate of is JavaScript good or bad here. We're just talking about what the skill sets are. But we know that there is a vast amount of people who know SQL. They are very comfortable with the native SQL of select statements and joins and creating tables and doing all lookups with what looks to them like SQL. And in existing platforms, in the legacy platforms, there is a concept of PL SQL, which is an extension to SQL to give more of a programming flavor to SQL. And with Snow scripting, that same programming capability is now coming to SQL, and you can do that natively in stored procedures or even outside of stored procedures. And we're going to talk about that. This is why this is really cool. JavaScript doesn't go away. You can still create your stored procedures and do procedural programming leveraging JavaScript. But if you are more inclined on the SQL side and you just want to write SQL, now you're in luck because you can do that and still take advantage of your knowledge of SQL, but taking the power of Snowflake to run that SQL from a procedural perspective. So a common question that might come up as we're thinking about this is folks that are exposed to Snowflake scripting, and the understanding is Snowflake scripting is SQL really coming to allowing you to create stored procedures. Why isn't it called Snowflake SQL stored procedures? Right, that might be a natural question to ask, and the answer to that is sure. Snowflake SQL stored procedure is one of this capability that comes up with this. You can write SQL in stored procedures, but it's more than that. You can do scripting even if you're not creating a stored procedure. And I think that will be the biggest takeaway from this, right? If it's just called Snowflake SQL stored procedure, well, what if you want to do scripting, but not necessarily in a stored procedure? And we'll see concepts like anonymous scripts and a lot of things coming into play where you want to still do some scripting and execute that script, but you're not always tied to the construct of a stored procedure. And that's why Snowflake scripting makes way more sense and it's a natural description of it than Snowflake SQL stored procedure. So what are some of the applications that we might see of Snowflake scripting are really coming into play yet? Lots and lots of applications. Number one is folks that already do data engineering, which is a huge, huge piece of the capability of Snowflake. You're bringing in lots of data. You need to transform that data with logic. SQL is a very capable language, but if you want to do conditionals and loops and maintaining states of different data sets, SQL falls short really quickly trying to do that, right? So the alternative is you can go do that in Python, which a lot of people are doing and leveraging Snowpack. Or if you don't want to learn Python and you want to stay in SQL, you can still use the familiarity of SQL and do all of that logic, but also having the flexibility of a programming type language. So you can do conditionals, branching, loops, you can orchestrate jobs, you can centralize your business logic, still maintaining that in SQL, and it gives you that flexibility. And then you can also do auditing with this. For example, data coming in, you do some transformations, you want to log in or maintain state in an audit table, you can do all of that by leveraging the power of Snowflake scripting. So if you think about SQL and really extending that, Snowflake scripting becomes extremely valuable. Now, there's a natural application here, which is not specifically called out, which would be thinking about migration from legacy systems like Teradata or Oracle or some of the systems that have PL SQL, and you want to bring that into Snowflake. Now you can. This doesn't mean that there is parity, 100% parity with PL SQL to Snowflake scripting. But given that the primitives are very much there, like looping and conditionals and branching, that migration now becomes a lot more easy. And I really encourage you to take a look at it and to see how it might play up in your own situation. If your need for Snowflake scripting is thinking about bringing existing code or migrating existing code from systems where PL/SQL was relevant into Snowflake, this will be something you really want to take advantage of or take a look at to see how it applies to your needs. Now, that said, as promised, this session wasn't just going to be about discussion. We also want to do a demo of it to get a hands-on feel of Snowflake scripting, and we're going to go into the UI and take a look. So here we have our canvas, which is a plain vanilla canvas. Let's just go ahead and zoom in a little bit more so we can see the scripts that we're writing. So Snowflake scripting, think about it as you come into the Snowflake UI, whether you're coming from the classic UI or you're coming from the Snow side, which is a more modern, intuitive UI to really elevate your developing experience. Snowflake scripting can be applied to either way. So what are some of the things we can do with Snowflake scripting once we get a hold of it? The very, very first thing that we're going to do, see here, is understanding the difference between Snowflake scripting when we're talking about it from Snow side versus Snowflake scripting when we're talking about it from the classic UI. There's a minor difference, and it's very important for us to just put that out there before we go in and do more scripts. If you're going to be picking this up, you want to understand those differences very quickly before we go in. So here we have a documentation. I always encourage folks go into documentation. I've worked with many different companies and seen many different tools, but when it comes to documentation, Snowflake is second to none. So go into the documentation, read those documentations. You would really get a good handle of it, and there are sample scripts in there which you can follow. That said, let's see how we do Snowflake scripting from the Snowflake UI. The very first thing that Snowflake scripting involves is you write a script in Snowflake scripting, and you can execute that as such. Very basic scripts, and we're going to go and dissect all of these scripts. But the syntax, you can declare some variables, you can begin some transactions to perform, and you have the predicate there to end this. All right. And there are keywords of declare, begin, and you can end. In Snowside, in the new UI, this syntax would work. I could go ahead and execute this, and there shouldn't be a problem. I'll have to make a change here or there. But if I go into the legacy environment, we can do the same thing, except there's gonna have to be a change. And the change there would be you're gonna have to use this $ symbols between any script you write. If you're kind of going back and forth, and a lot of folks are going from classic to the modern UI, just be aware of that once you switch over, you're not going to have to put in this pounds or $ symbol in your script. That's just the fundamental difference. Every now and then I'll switch back and forth. You can see the difference. But if you notice on the Snow side of the world, we don't need this anymore. You can just write your code and execute it as such. A foundational thing to take out the door and make sure we understand. Now, let's go into the second concept that we want to be aware of once we understand the differences between the Snow side for Snowflake scripting and the classic UI. Is let's understand the blocks with Snowflake scripting. Snowflake scripting gives you way more flexibility than just native SQL would give you. And This introduces concepts of blocks or anonymous blocks. For example, here we're gonna try to calculate the radius of a circle. All right, and here we can declare a bunch of variables. We're gonna put in begin, and in there we're doing a calculation for the radius of a circle, and we're gonna return a result. So this is just regular scripting, and we're doing this in Snowflake scripting. So I can go ahead, select that, run that, and we get a result. And what this tells us is this is an anonymous block. Why? Because we're doing scripting, but we're not putting this in a stored procedure. We can put this in a stored procedure and it'll have a name and it wouldn't be anonymous anymore. So you start hearing the concept of anonymous blocks is because you can do scripting without a stored procedure. And that's why, as we mentioned earlier, it's not called Snowflake SQL stored procedure. Is really Snowflake scripting because it's a scripting language, even though it's SQL. All right, that's an anonymous block, and we can do many of that, right? There are many different ways you can do anonymous blocks. You can do a block where you declare a bunch of variables. You can use those variables in your begin block, or you can just begin without necessarily declaring variables and just perform your DDLs or your DMLs directly inside of the begin statement. Here we can create a table, we can create a child table, and we can return that will complete. If you think about taking all the SQL code you have and putting them into this block, it gives you way more control in terms of organizing code and encapsulating logic in a very flexible manner. Now, let's look at the next concept. Once we've seen blocks, we're going to do a lot of block creation. Let's go into some more examples to see how to leverage blocks for creating stored procedures instead of just creating anonymous blocks, because we can do scripting anonymously, but what if we want it in a stored procedure we can reuse over and over? All right, it's very similar. We're creating a stored procedure here. And what is the language? SQL. Now, within that, we can go ahead and write out Snowflake scripting here. And this will create a function for us that can calculate the area of a circle. Now, if you notice in this piece, because we're running this on Snowflake, this is what the syntax looks like. But if we went over and we did the same thing in the classic UI, in the legacy UI, and I've switched over to the legacy UI, what are we going to do differently? I'm sure we can guess now that we're going to have to include the $ as such. We're going to have to end it with $ as such, right? This will be required if we're running this script in the classic UI, but in the Snow site, the new UI, this is not required anymore. Again, just really doubling down on that point to make sure we get that. So if we come in here, we can create a stored procedure. And this stored procedure is just going to calculate the area of a circle for us. And like any other stored procedure that we have, we can go ahead and call that stored procedure and invoke that, and we're going to get our result. The area of this particular circle of radius 3 is so and so. All right, so that's something we've done. Now, for folks that are more inclined on JavaScript, you can write this logic in JavaScript, right? There's really nothing exotic about this. But if you prefer SQL, now you can do something like this in SQL and have that flexibility. For the person calling this stored procedure, it's transparent to them. They don't know if it's a SQL stored procedure or if it's a JavaScript or even Python, which is a whole different topic, or even Scala. To them, it's just a stored procedure in Snowflake, and they just invoke that the way they normally invoke every other stored procedure. A very flexible way to democratize access to logic for different skill sets. People who can write SQL, Python, Java, Scala, you name it. It becomes very easy to do all of this with Snowflake scripting. Now, let's go into the next topic, which we're going to look at here, which is working with variables when it comes to Snowflake scripting and how flexible this is. As we can imagine, in the normal SQL world, you might think of doing something like this if we're trying to declare a variable. Let's say I have a variable, my variable, and I want to set that variable to a particular value. All we do is this colon and equals to sign. We're not doing something like this, which is what you see in some other programming languages. With Snowflake scripting, this is the way to assign a value to a variable, right? This is an assignment operator. Now, if we do that, we can go ahead and use it. Let's do a variable, and then we're going to go ahead and begin with a keyword. Let's return this my variable that we just did, right? Let's go ahead and return my variable and see what exactly is going to happen. Let's end this And this should be a very simple statement. Okay, if we have my variable, I can go ahead and I can return my variable. And what should we get? We get a problem here. We get a problem because it's saying unexpected my variable. What can we do to fix that? We can either take this, let's just go ahead and bring this in here and say let my variable equals to that, and we can return my variable. There are many ways and flexible ways to work with this. So let's go ahead and do that. If we are trying to work with a variable, we need to declare that variable. Either the variable gets declared outside or inside. Now I'll explain why outside did not work, and at that point we start understanding the concept of blocks. For now, let's just work with begin and end. We can declare a variable, and we need to use the statement here, let my variable equals to 5. Essentially, we're getting the square root of 5, and we're returning that. Now if we wanted to do this, and I'm sure we saw this when we try to put this outside, when we're doing it outside, we don't need to put the let anymore, right? We can just declare a variable. But there is something wrong here. Like, why wouldn't this work? If we go ahead and we run this, why would this give us an issue? Again, it goes down into that concept of blocks, right? We need to specify that this is a declaration, that we're going to declare something here, right? At this point, whatever variables we want to declare, we put them into this declare statement. If you miss it, it's not going to recognize that we're doing a declaration of variables. Right now, we've declared my variable. I can go ahead and run this, and it's going to give us 5. If I don't want to do it that way, then that's where the second option, as we saw earlier, is we take that and we let that as such, right? And then we can get rid of that. It's very flexible ways to declare variables and to use the variables you declare for processing. If you're going to do scripting, a lot of times is because state changes a lot, you're going to be declaring variables, updating, setting those variables, and changing things. So really understanding how that all works becomes a very essential skill to have. Continuing with this whole idea of variables, which we've seen, we're going to look at another example here, more in depth if you're working with variables. As mentioned earlier, you can declare a variable, in this case, profit, and you give it a data type. Of course, you declare a variable, you're giving a data type. We can even give it default value. Here, we're going to set a default value of 0. And then cost in itself, we're not declaring that, we're just putting that within the begin. As such, we need the let statements. We need to let cost be set to 100, right? And of course, we still have the data type specified. Now we can do some logic. We're going to calculate profit, which is the revenue minus the cost. Again, very basic logic all done here. And this should give us an idea of declaring variables and then using those variables to perform logic in a scripting manner. It gets really interesting where not only can we declare those variables, but we can also start passing variables around. And we want to touch on that here really quick. Let's hide the results so the screen is all clean. Let's look at dynamic variables. Here we're going to create a very simple table, and we're going to load 2 records into that table. This will be sales data. We're going to load in just 2 records, keeping it really basic, really simple. Let's go ahead, execute that, and the sales data has been created. Now, let's see how we can work even more dynamically with variables. What we're going to do here, we're going to declare 2 variables, integer, int, which we had in our table, we just created, and then the name of that integer. All right. Now here we're going to begin. We're going to select into the 2 columns, right? This is we're working in with that sales data. We're going to select ID, and we're going to put it into this declared variable called ID. We're going to select name, and we're going to put it into the declared variable called name. So, and this is where procedural programming or scripting really starts becoming more flexible. You can start doing things like this, setting state, changing state as such. To leverage a variable as such, we need the column and the ID in front of it. That tells us that this is not the name of a column, that this is the name of a variable we've declared before and we're using it. So ID goes into ID and name goes into name from sales data, and we're just going to print that on the screen, concatenate the both results. What should we get here? We're going to look at sales data table. We're going to get the ID and the name, and we're just going to string that together and return that to the screen. Let's go ahead and run this. The first record in there, which we're just getting where ID equals 1, of course, was 1, and the value was A, and we're just concatenating that on the screen. But you can start seeing how to take variables and work with those variables in a very dynamic fashion, and Snowflake scripting allows us to do that. Now, the next concept we want to touch on beyond just setting variables is the idea of returning values from specific functions or from specific logic we've written. Here, let's take a look at returning a scalar value, which is something we typically would do a lot if you're creating stored procedures. A lot of stored procedures, it does something and then you want to return some result, maybe a scalar result, but not always. And we're going to see the difference. Here, and scalar simply means a single value. Here, we're going to create a simple function again to calculate area. And we've already seen the concept of declaration, variables, being able to put things in begin where our logic happens. And once we calculate the area of a circle, which is pi the radius squared, we're going to return the area of that circle. Pretty straightforward, right? If we go ahead and create this stored procedure, which is leveraging Snowflake scripting logic, in there, we can invoke that stored procedures. We can go ahead and call area, and it should calculate the area and give it to us based on radius being 3. Let's go ahead and create this. We're getting the area of that circle and we're seeing a result. Let's bring this back up here. This is a singular result. It's one result coming back. Very straightforward. This is common ABC. You can almost think about this as a function, right? Give it an input, it gives you a result based on that. All right, even though I wouldn't call this a function because we might change state here, but that's a whole different conversation. Returning a single value or a scalar value from a stored procedure is very straightforward. But what if we want to go beyond just returning single values and we want to do something like return table values from stored procedures? You can also do that. And we're going to see how to do that here shortly. We have this script here where we're going to create, again, a procedure looking at our sales data, so SP stored procedure. And instead of returning a scalar value like we did, now we're going to return a table. All right. And the way we preface that is table. We define what table result set we're going to be getting back. And now in here, we're going to go in, we're going to declare a result set. And you hear me use that a little bit earlier. So we're declaring within a declaration block a new variable, but it's of type result set. All right. This is really important. Declaring result. What type is it? It's not an integer. It's not a string. It's of a result set type. What is the default for it? If there is nothing provided, we're going to return this result, right? We're just going to select ID from our sales data, and we're just going to bring that back as a table, as a result set. Once that declaration has been done, in this case, we're just returning the default. We're not really doing much here. Let's go ahead and create this stored procedure. And if we have this stored procedure and we invoke that, instead of getting a single value, we're getting a result set. Very, very powerful. There might be use cases where you're not just working with singular values, but you want to return tables or result sets to be used for further processing. This allows you to do that with Snowflake scripting. Now let's dive into more what people will be more familiar with when we start thinking about procedural programming or scripting programming and applying logic and conditions based on that. So if my data shows up, I want to do this. If sales amount is less than this, I want to flag this customer as high risk. There are a lot of business logic that really depends on conditionals. To me, that's really a foundation to programming. If you understand this concept, you can be a programmer very easily. Here, we're going to see how working with branching within Snowflake, there are really two types: if, else, and then okay statements. This is something that we should be familiar with. Let's take a look at the if side of things. So how do we do if statements within Snowflake scripting? Now, we're going to use anonymous scripts here, but of course, you can put all of this into a stored procedure. A lot of the demo as we go forward, I'll be switching between anonymous scripts or just putting them in stored procedures, but you have that flexibility. So here, what are we going to do? We're not declaring anything. We're just going to begin. We're just going to let count. Now, if count is less than 0, we return negative value. Else, if it's equals 0, we return 0. Otherwise, we say it's a positive value. All right. Very simple conditional logic that we can check. What should this return? We've declared count as 1. I'm sure we can guess what this will return. Let's go ahead and run this. What should we see on the screen? It's a positive value because we're going in and we're returning this. But what if I did minus 10 as an example? Okay, what should I give us? The conditional should print negative value. And if I did 0 here, okay, conditionals should give us 0. Of course, we can do conditionals and branching within SQL using scripting language. And this is very powerful. You might say, hey, if my sales data hasn't showed up, don't process my dimension tables. And a lot of things like that become possible if you can put in conditions into your statement. And that's why Snowflake scripting becomes very powerful. Folks might be asking, why no SQL? Why do I need scripting? This is exactly why scripting becomes really relevant. All right, if we can do conditionals, there are really two ways to do conditionals in most programming language. Number one is if statements, like we've seen. You set some value you want to check on, and then you put your conditions. If that value is less than this, or if the value is equal to this, or greater than that, you can do a lot of equivalence checks. That's a whole different concept. I'll recommend you look at the documentation, but this is a foundation piece of it. Now, the next way of doing checks, which doesn't use if statements, is leveraging case statements. Now, there are people that love case statements. There are people that just cannot stand it. They both accomplish the same things if you're going with the case statements, but it's all about conditions. You want to execute something based on certain conditions or certain predicates. Here, we're going to declare an expression, some expression to evaluate. We're going to give it a default value. So the default value is that. Now we're just going to check, and this is the syntax for it. So within our begin, we're going to go in and check to say, hey, let's set that value to value A. All right. Now we've just basically set, that's just an instantiation of this variable. Now let's do a case. We do case, then we just, what case are we going against? We're going against this variable. Case this variable. Now we go into our case. When it's value A, then return X. If it's value B, return this, right? Basically, almost like an if statement, but some folks, it's a more intuitive way of writing if statements. So in this case, what is this value A? What should we expect? We should return X because it's going to evaluate at this return statement, right? And when it returns, that the execution ends because return is the end of that execution. Let's go ahead and run this. As we expect, we should get X, right? But if I change this to value C, let's keep it the same case, we should now be evaluating to returning Z because the case statement is now executing at this point. When this is value Z, return this. All right, we can do branching, conditionals, and a lot of things leveraging the power of Snowflake scripting. Now, native SQL doesn't give you this. You need that extension of Snowflake scripting to accomplish something like this. Now, next piece here, and this is a big area that a lot of folks really get to be familiar and flexible with, is working with loops as well. Now, like I mentioned earlier, programming really is a couple of things. If you understand the concept of conditionals and branching, and then you can put in loops and iteration on that, for the most part, you've understood the main concepts of programming. Here, we're going to be looking at working with loops: for loop, while loop, repeat loop, loops. All right, let's start with the very first one. Here, we're going to declare some variable with the default value of 0, and we're going to declare count, and we're just going to begin. Inside, we're just iterating through that count. So for I between 1 and max count, we're going to just increment the counter here. And once that loop has executed and is done, we're going to return how many we've counted. Once our max count is 5, we're just basically going to count from 1 to 5 and sum that up. All right, because we're just adding 1 to it each time. Let's go ahead, execute this. And what should we get? We get 5, right? So each time we're adding 1. But this is happening within a loop, right? If I wanted to do, my max count was 500, as an example, it's just like counting from 1 to 500 here, right? Nothing really fancy. It's that quick. Now, this is where the power of Snowflake really comes into play. When you count to 5 million, you can take advantage of the power of Snowflake in this case, right? Because we're seeing a lot of the scripting, but behind the scenes, the full power of Snowflake is there for you to use at any point in time. We're counting to 5 million, and I'm doing this with a very small warehouse. If this wasn't performing, I could just in the dime spin this up to a larger warehouse, and you're gonna see the result. Very common. I think most people already know how to do for loops. You can do all of that with Snowflake scripting for the most part. Now let's take a look at, this is a for loop with a counter, right? Here we have a counter, and we're iterating through that. But there are different ways of doing a for loop. You might have some list or some collection or some array, and you want to iterate through that and perform a certain action on it. You don't always need to have that counter. You can certainly do a for loop without that counter, and in that case, you'll be doing a for loop leveraging something like a cursor. So let's take a look at how this will work. If you're not familiar with cursor, we're going to be touching that a little bit down the line. Just stay tuned to what cursors are. Now, let's look at the for loop with a cursor. For us to make this happen, we're going to create some table, a simple table, insert 2 invoices into that table, and then we're going to see how we can look through those invoices and maybe calculate something about those invoices that we can send for reporting. Now we have a base table ready for us to use. Let's go and walk through those invoices that are available in that table. Here, let's go ahead and declare total price, and then we're going to create a cursor. Now, again, if you're not familiar with your cursor, this is something that becomes really, really key. I'll be touching that a little bit down the line. Just kind of hang on that. We're going to declare cursor, which is going to be the result of that cursor is just going to hold the result of the price we've selected from our invoices table. So we select all the prices from our invoice tables, we put that into a cursor, and then we can just go iterate through that cursor to perform a certain action. Here, we're going to go begin. Now that our cursor is going to have that value, we're going to set our total price, initialize that to 0. And from there, we're just going to, for record in cursor, do this action to it. All right, becomes a lot simpler. For every record that exists in C1, which is the cursor we define, now perform take total price plus record price or do whatever math, and that's what is done. And then once we're done with it, we return the result. All right, let's go ahead and execute that. And now we see the result of this plus this was basically just summing all the prices in our invoice table to get that result. So the first way we saw of doing a for loop is a counter, and we're iterating through. We're saying for we said for I in starting from 1 to max. Let me actually bring that to the screen. We can see the difference of the syntax here just for the sake of it. The first way we did it was for I in 1, starting from 1, counting to max count, do something. All right. This is the first way where we're using a counter. In this case, we're just saying for record in C1. And you can only do this with things like cursor, because the cursor, the easiest way is think about it as an array, and you just have to iterate through the array to perform a certain task. Many different ways of doing logic with Snowflake scripting using for statements. Now let's take a look at beyond for. If you're going to be doing looping or iteration, you can do it with for loops, or you can also do it with while loops. While loops, again, used to be very popular. It's kind of going out of favor, but it's still a very powerful tool to have in your arsenal if you're going to be processing data. Here we're going to declare a counter in this case, and we're going to do a power of 2 for that counter, right? And then here we're just going to go in initialize some 2 values as such. We're going to start with the counter, which is 1. While it's less than 8, we're going to do a power of 2. We're going to increment our counter. All right. And eventually counter will be greater than 8, and we're going to break out of the while loop and we'll return our result. That's really the power of a while loop. Okay. Let's go ahead, run that. What do we get? 256. Okay. And we're doing all this logic in a while loop. The next piece here too, where we can do all of this, as we've seen, using anonymous scripting, or as always, we can take all of this logic, put that into a procedure, right? Let's call this a procedure, because it gets confusing when people think about function. So let's put that into a procedure, and we're doing the same logic, but we're just going to call that from a procedure. All right. If you don't want to do anonymous functions the way I'm doing, create or replace. So let's create or replace that. Let's create or replace. There we go. Now we have a procedure which we can go ahead and we can, if we want, we can invoke that, right? We can call that power of 2 and we get the same result. And you can just call this over and over. So that's working with while loops. Now, there is a concept of repeat loops, and we're going to talk about loop loops. But again, if you're not familiar with this, I highly encourage you to check out the documentation. These are other options that are available for working with looping statements or iterations of data. That just gives you more flexibility beyond while loops and beyond for loop. Let's go in here to look at what a repeat loop is all about. In this case, we're gonna again let some initial values be declared, and we're gonna just say, hey, repeat inside of, and then within that repeat block, we're gonna perform some certain action, some certain transformation until a certain condition is met. Then we break out of that repeat. And this is for folks that, I think a lot of folks that watch this channel are pretty advanced. We're not going to be going into basic tutorials of while loop and repeat loop. We're just calling out the syntax in Snowflake. But if you're not familiar with this at the very fundamental level of looping and conditionals, I would highly recommend you do, because If you don't have the right conditions to break out of loops and you end up with the wrong loops, or while conditions that never break out, you end up with issues, right? You run out of memory issues, you have codes that break. These typically are places in code where you have to really understand what you're doing to make sure that if you're going to be repeating something, when you repeat, does your end condition, is it ever going to kick in, or is going to repeat it to a point where there is no end condition, and then you run, your code crashes. So just something to be aware of, especially more for the beginner types that are just seeing this for the first time. I think a lot of folks on the channel are pretty advanced, but if you're a beginner, I would just really recommend just understand the foundations of programming so you don't run into some of those issues. Here, let's just repeat this. We're just gonna basically repeat and then add that until we get to 5, very similar to the addition we did. But in this case, we're doing the repeat loop, right? And then last but not least is one of my favorite, right, to call and to pronounce, which is a loop, right? Here we tell it to loop until a certain condition is made, and then otherwise we break out of that loop, right? Instead of using the repeat, we're gonna just tell it to loop. If counter equals 0, then we break. Otherwise, we just keep subtracting from whatever value until we get to 0. So if I start with 5, it's just gonna loop 5 times, subtract 1 until it gets to 0, and then it returns counter for us. Not very, very useful if you're gonna be doing some things around your use case. But from a tutelage perspective, hopefully it gives us an idea of the syntax and the functionality that's available to use. All right, what we've seen there, just to summarize in this particular case with conditioners, is a whole lot of things. When working with conditioners and iterations, you can work with loops. There is a for loop, there is while loop, there's repeat loop, there is a loop, which you can use again based on how you want to structure this. So if you combine iterations, which is looping, and conditioners, which is branching, and if or case statements, you can do a lot of stuff, right? You can do a lot of stuff. Let's move on into the next area here, which would be working with cursors. I think I promised there that we were gonna touch on cursors really quick before the end of the presentation here. So let's look at working with cursors. And then more specifically, we're gonna see how to bind values from cursors to make code a little bit more dynamic. And there's a lot of things that you can do with this. Here, we're going to declare a couple of variables, ID, minimum ID, and then we're going to create a cursor, which we saw a little bit earlier. And cursors typically do what? They hold data sets from a table, right? That's basically what a cursor is. Think about it like an array. I think I that in my head, I store it that way, just to understand it from a conceptual perspective. Now we're creating a cursor which is going to select ID from sales data, where ID greater than what? We don't know yet, right? We're just going to use this question mark, and this is where we're going to start seeing binding of variables coming into play. Greater than what? Well, we don't know. We're going to do it as a question mark. Now we're going to go in and begin. Now, this is where we always do our stuff within begin. Open up a cursor. Even though we have a cursor here, it's almost like lazy loading. It doesn't execute, it doesn't evaluate until we open up that cursor, right? Open up the cursor using minimum ID, and then we're gonna fetch from that cursor into ID, and we're gonna return ID. All right, let's just kind of, a lot of things going on here. Let's break down what's going on. Now, open cursor using. Now, using is something we've introduced here. Why don't we just open cursor? Why do we have to say open cursor using? Why we're doing this is we're binding a minimum value, which we've declared above, and sending that to the cursor, because we have this question mark on the cursor. We need to bind and to pass a value to this, because otherwise it doesn't know what value to use. That's why we're using this binding here to send the minimum ID. When this executes, it's gonna, think about it as it's going to select from sales data where ID greater than 2, right? That's essentially what we're doing, because we're doing this binding of using. Now, once we've done that, then we can fetch from our cursor, and we'll putting that into this ID, and then we're just basically returning ID. So if we run this, what should we get? All right, we're selecting from here where ID greater than 2. We're going to select from all our sales data where ID greater than 2. So let me go ahead and just run that so we can take a look and see. Might have truncated. Did we truncate our sales data? Let's just check this really quick. Okay, there you go. Makes sense. Makes sense. I think we're all good here. The reason is in our sales data, we have just 1 and 2 for IDs. ID greater than 2, of course, will not return any result. If we wanted to see results, let's make ID greater than 0, because then we should see some stuff there. So let's go ahead. Now ID greater than 0, now it gives us that 1. If we do ID greater than 1, it should give us 2 in there. Makes sense. But this gives us the idea of understanding working with cursors. We can iterate through those cursors, which we saw a little bit earlier. We can do binding of variables to cursors to make the code more dynamic. Lots of things that can be done. Now, the next thing that we're going to look at is, in addition to cursors, there's another construct, very, very common in working with kind of scripting languages, like we're seeing here with Snowflake Scripting, which is this whole idea of result sets, right? So with result sets, very similar to cursors, but it allows you to get data almost like a table, and you can perform actions on it. Let's take a look at result set and how we can assign queries to declare result set, and we can construct statements dynamically. We can return tables from stored procedures. So this is really packed with a whole lot of stuff, right? This particular example was seen here on the screen. Let's declare a result set. Number one, column name, we're declaring that, and the select statement. This is a SQL statement we're going to build dynamically. A lot of folks like dynamic SQL. You can do it, and this Snowflake scripting gives us the flexibility to do that. So here, let's create column name. We're basically setting the column name as ID. Now we're going to build our statement, right? So select. Now we're replacing a column name ID from sales data. Just think about dynamically building that. And then here we're going to get our result set. And what is it going to do? We're going to execute the select statement. And again, remember all those syntax are coming into play here. By using select statement, we need the column because we're telling it it's a variable we've declared that we're trying to use here. All right, we're going to execute the statement, and the result is going to be persisted in the result set, which is declared above, and we're just going to return that as a table. All right, we're going to return that as a table. Let's go ahead and execute this. A lot of things happening here. We're seeing result set coming into play. We're returning tables. We're doing dynamic queries, and we're executing that immediately. And this just gives us a lot of flexibility. All right, a lot of flexibility here for us to use. Now, I would recommend, if to understand the differences between result set and cursors, I'll leave a link in the documentation below. If that's something you want me to make a video about, just let me know in the comment section, and I'll see what I can do about that, because sometimes it's very confusing when and where to use result sets versus cursor. All right, because you can ask, why didn't we use cursors here and we're using a result set? So if you want me to make a video about that, let me know in the comment section below. I'll see what I can do. Now, next thing is 9, getting close to the last but not the least, is determining the number of rows affected by DML, especially for automation and quality checks. You might want to know, when performing a DML and modifying records, how many records are affected for reporting purposes, for troubleshooting purposes, or for just governance purposes. And Snowflake gives us the primitives to do that. But here, let's just go ahead, and we have our table, which we call sales data. We're just going to go ahead and insert 2 records in there. Nothing to write home about. Very, very straightforward. And then once we do that, maybe we want to put into a login table to say, hey, we updated 2 records in that as part of that insert. All right, let's go ahead, do our begin here, which will begin and do the insert. Once it does the insert, then we're gonna make sure we're selecting everything from there. But one thing we're also returning is this select row count, which is available to us once we do a specific DML operations, right? This will return the row count of the last DML statement that we executed. Let's actually, yeah, let's just go ahead and run this, and we should see 2. So there we go. Why do we see 2? Well, we've executed an insert. This is a DML statement. It's modifying 2 records. We're doing a select. A select is just, we're not modifying any record. It's just giving us result. When we call this select row count, which is a global, think about it as a global immutable variable in Snowflake that you can access to get the last DML that was operated, it gives us 2 because the last time we executed, we updated 2 variables. And there are a whole lot of reasons why you might want to do this, right? You're loading data for some feeds coming in, and you want to know how many records were loaded. You can always do a select count before your insert, but you might not always know that, right? After the DML, you can just take the SQL row count and process that into a login table that could be used for audits, right? Or used for other governance purposes, or used for just data quality to check your data. A whole lot of reasons why this could be very, very useful to use in terms of determining the number of affected rows. Now, last but not least, so we're getting to point number 10 here, which is working with exceptions, declaring exceptions, raising exceptions, and handling those exceptions. Now, it's a little bit more of an advanced concept, but worthwhile to know nonetheless. Let's go in and see how we can raise exceptions. If you've programmed in Java in particular or other programming languages, you're going to have to do some exception handling pretty quick. So here we're going to declare an exception, and this is what the text of the exception we're going to raise. Now we're just going to let a couple of variables. This is just we're forcing us to raise this exception. What's the name of our exception? My exception. And we're just going to put a boolean here and make it true, right? By default, we're setting it to true. If we do our conditional check, it would always be true because we've set it to be true. Now we're forced to raise an exception, and this is how we raise the exception. We're going to raise my exception, which we've declared above, and guess what? We should see this coming to the screen. All right. You can declare exceptions and then raise those exceptions in different areas across your code. You can see we've raised our exception 2002. This is not just an error. This is an exception we specifically raised, and somebody can watch for this exception and go fix something about it, right? That's the beauty of exceptions, because you anticipate where an exception will happen. You raise that, somebody can go do something about it. All right, we can raise exceptions, but it's not fun if all we do is raise exceptions, right? Then what? Like, it's just like being that friend that always complains about things that are not going well, but then what? What are they doing to fix it? How are they handling the exception? How are they fixing the situation or catching that exception? Which is what is common in the programming circles. Here, we're declaring again our exception, which we're gonna raise, but this code looks a little bit busy. Trust me, it's not. It's just for demonstration purposes here. We're gonna declare my exception, and this is 20,002 is what that is about. We're gonna set a counter. Again, should we raise the exception? True. In this case, from the block of code we saw earlier, we're gonna raise an exception because this would be true, and now we're gonna raise my exception. Now, remember, we have our declare block, we have our begin block. Now we're going to have to introduce a new block here, which is exception. Now, if we've raised an exception, the exception block would catch it, right? This exception block is new. We've seen declare, we've seen begin. So now in this exception, we'll put in conditionals, and this is the beauty of why we use conditionals. When the exception is my exception, which is what we declared above, my exception, we're gonna return this object, right? Now you can give a more descriptive statement of that exception. So we're gonna return an object. Here we can get the SQL count, right, which we saw a little bit earlier, of counting the number of rows affected by DML. We can get the SQL code, we can get the error message, we can get the state. There are a lot of things that you can access now and surface that. The people troubleshooting know exactly what to go fix or how to resolve this particular exception. So it's one thing to declare exception and raise them, but it's another thing to go in once an exception has been raised and to handle it. Let's go ahead and run this statement. Now we don't get an error because we don't have an uncut exception. The exception has been handled. The previous execution of this, when we ran it, we raised the exception and we didn't have an exception block. It came off as an error, right? But here, because we have the exception block and we're actually handling the exception, now we're not having an error. We have a message that somebody can look at this and see, oh, what exception is in my exception? It could be exception of sales data not found. It could be the exception of missing customer. Whatever it is for your business case, you can raise that exception with the appropriate code and a bunch of other metadata that could be used for troubleshooting or for debugging, right? And one thing to consider could be, let's say, again, in this case, we can begin here. We do a select statement from a table that doesn't exist. Well, what happens if a table doesn't exist? We can raise an exception, and within the exception block, we can now go in and maybe insert into an exception table, into a login table, into kind of a handling table that somebody can go audit to know what's going on with the system. And you have a lot of flexibilities to do this. So very, 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 very powerful capabilities that we've seen. Now, this, if you've watched to this point, thank you. It's a long presentation, it's a long demo, but it's very important to just walk us through, and hopefully you've seen the syntax, you've seen how simple it is, and it's powered by Snowflake behind it, and it doesn't even get any better than this, right? If you want to create any amazing Snowflake scripting, you always know you can write that and you can take advantage of Snowflake's elastic compute and scale and cost effectiveness to execute those scripts at scale. And you can also do legacy migration and a lot of things. Snowflake scripting is a very powerful capability. Let's just take a look at what we've recap of what we've seen. We've seen a lot of stuff: control logic, if-else statements, case statements, looping statements, and how to go through while loops, for loops, loop, and you name it, right? We've seen features like inline SQL, binding variables, result sets, cursors, transactions, logging. We've also seen error handling, raising exceptions, catching those exceptions. There are more concepts like owner rights, and especially when you're creating stored procedures, owner rights versus caller rights, and then anonymous scripts too, which we also saw. This has been jam-packed with this. My hope is now this is kind of 101. You have the foundations and the primitives understood, where you can then take this to say, how does this apply for my use case? How can I build and take advantage of Snowflake scripting within my workload for data engineering, data transformation, data warehousing, or curation, to really elevate the game and to build amazing data products. Hopefully this was helpful. As always, thanks to everyone for joining and watching this. I have been through doing today's demonstration here with Demohub. The video will be available on Demohub. And if you found this valuable, give it a thumbs up. Share this with somebody that might get value out of it. If there is any topic you want us to make demonstrations around, let us know in the comment section below. If there's any tool you want me to bring guests to the channel to do demos about those tools, again, let me know in the comment section below and we'll see what we can do. Check out the Demohub.dev link, create a profile, share it. We can get more demos curated and collected as well. Again, thank you so much for watching. This has been Fru. You have been awesome, and I'll see you in the next demo.